May-June 2024, Paper 2, Variant 3. Question 1, A, Part 1. Explain the lack of reactivities of nitrogen gas. So first, let's focus on the structure, the bonding between the nitrogen atom. In the nitrogen molecule, so we know that there are 3 covalent bonds between the nitrogen's atom. So this triple bond is extremely strong and it's hard to break. When we say the molecules or the species react with others, so the molecules need to undergo bond break. Then it can react with others and form a new compound. So it's just because of this triple bond is too strong and it's hard to break. So therefore the nitrogen's molecule is not likely to react with others or not easily react with others. So therefore the first point that you need to mention is this. The nitrogen's molecules have the strong triple bond and is required large amount of energies to break them. And the second point that you need to mention is the polarity. So we know that nitrogen's molecules are non-polar. Why is non-polar? Because the 2 nitrogen's atoms, they have the same electronegativity. So therefore this nitrogen molecule is non-polar molecule and is also less likely to react with others. Okay, I give you one example about the polarity with the related reactivities. Okay, so now we have the 2 compounds. We have the methane and the chloromethane. So for those who learn organic chemistry, so you know that when there is a hydroxide and the halogenal alkane, like this chloromethane, so there is a reactions between these species. So it will undergo a substitution. But when we put the hydroxide together with methane, so this hydroxide will not react with the methane because methane is actually a non-polar molecule. So the polarity also will affect the reactivities. So therefore you need to mention these 2 points. Part 2. Covalent bonds can be sigma bond or pi bond. Complete table 1.1 to show the numbers of sigma and pi bond in the nitrogen's molecule. In order to fill up this table, first you need to know in the NN triple bond, so how many sigma bonds in there? Whenever there is a multiple bond, it will be only 1 sigma bond. The remaining is pi bond. So therefore we know that in this triple bond, it will be 1 sigma bond and 2 pi bond. Once we figure out the numbers of sigma bond and pi bond, then we need to get the types of hybridization, because we need to know the hybrid orbitals, or we want to get the hybrid orbitals for the head-on overlap or direct overlaps. So for the nitrogen, okay, we know that there are 5 valence electrons for each of these nitrogen. And if you undergo sp hybridization, and there are 2 sp hybrid orbitals formed, and 2 p orbital means these are the 2 orbitals that unhybridized. So this unpaired electron in the sp hybrid orbitals, it will use to form the sigma bond. And the 2 unpaired electrons in the p orbital will use to form the 2 pi bonds. So that's how the thing works. Means each nitrogen, they will have the same hybridization like this, and they will undergo different overlaps. To form the sigma bond, it need to use the sp hybrid orbital, means these orbitals. And if you undergo head-on overlap or direct overlaps, something like this. This is the hybrid orbitals, one of the hybrid orbitals from one nitrogen, another hybrid orbitals. So it will undergo these direct overlaps to form the sigma bond. For the pi bond, everyone should know, in order to form this pi bond, it will be the p orbitals and its overlap sideways. So therefore, we know that how the orbitals overlap is sideways overlaps of the p orbitals, and it's formed the two pi bonds because there are two unpaired electrons in the p orbitals. Part B1. A sample of aluminum reacts with excess chlorine. State the oxidation number of the aluminum in the products of the reaction. Oxidation number of the aluminum, for the product, normally it will form this dimer, right, Al2Cl6. For the AlCl3 and the Al2Cl6, the oxidation number of aluminum is actually the same. So this one is -6, and aluminum, it must be +6/2 because 2 aluminum there. So therefore it's +3. Nowadays, if you want to mention the oxidation number, it's better to give the Roman number in the latest syllabus. So the means they will prefer this answer in Roman numeral, right? So you all need to be aware on this. Part 2, state what determines the maximum oxidation number of the period 3 elements in their oxides. Okay, so let's refer to this table. These are the period 3 elements from the sodium to chlorine, and this is their oxides. And the oxidation number of the period 3 elements is from +1 until this +7, from sodium to chlorine. So the relation is quite obvious now. The oxidation number is most likely because of the valence electron. Group 1 has 1 valence electron, so it's +1. Group 2 has 2 valence electron, its oxidation number is +2. This is group 13, so it's +3, means 3 valence electron. And therefore we are quite sure now the oxidation number of the period 3 elements in its oxides, it depends on the numbers of valence electron. Part C. Separate samples of the aluminum oxide and phosphorus oxide reacts with excess sodium hydroxide at room temperature. Okay, part 1. Give the state of the aluminum oxide and phosphorus oxide at room temperature. This is very easy. Both oxide, they are solids. Okay, so both together, 1 mark. Now, part 2. Write an equations for the reactions of each oxide with excess sodium hydroxide solution at room temperature. So we know that aluminum oxide is amphoteric. It can react with the acid and the alkaline. So everyone's already know and learn this one. So oxide, these are aluminum oxide will react with the sodium hydroxide solution with water, of course, solution, right? So it will form this sodium tetrahydroxyl aluminate, and this compound is soluble, right? So it will form this salt. And for this second equation is actually quite new to many of you, because normally in the syllabus or the textbook it will be just this phosphorus oxide with water, which form the sulfuric acid. Now it's asking the reactions between this acidic oxide with the alkaline solution, sodium hydroxide. If you want to get the equations correct, you can do this step. If you are very good in this, you no need to do. Okay, so this is just the guide to get the correct equation. The phosphorus oxide first will react with the water in the alkaline solution to form the phosphoric acid. And the phosphoric acid that form will further react with the hydroxide in the solution to form the salt, Na3PO4, and the water. And this is of course a neutralization. So we just sum up these two equations and get the OR, right? So we just remove the phosphoric acid and we just remove the water on left, 6 remain. So then we get the equation, right? So this is how to get this equation. For the part D, the oxide of silicon reacts with calcium oxide in the addition reaction to produce a calcium silicate, CaSiO3. Oxidation number of calcium in this compound is positive 2. Part 1, deduce oxidation number of silicon in this calcium silicate. It's quite easy. Since already given calcium is positive 2, oxygens must be negative 2 times 3, so it's negative 6. So the oxidation number of the silicon must be positive 4. Okay, as I told you just now, when you give this oxidation number, it's better in this Roman number, right? So it's positive 4. Part 2, calcium oxide can be made from calcium carbonate in a single step reaction. Identify the type of reactions that occur. So calcium carbonate can form calcium oxide when we heat it. So when this calcium carbonate decompose, it will form oxide and CO2. The type of reaction is very easy. So it's thermal decomposition. Okay, that's all. Thank you.